We are now entering module 8 of our course, which is the final module, that is the chemical project economics. In this lecture, we shall get an introduction to an extremely interesting topic of the economics of a chemical project. Chemical projects have a special status in the sustainable development of our country, because our society, we need chemicals in our day-to-day life in several forms such as dyes, soaps, detergent, cosmetics, food preservative, pharmaceutical, fertilizer, the fuels that run our cars and vehicles, two-wheelers, various metals that are there in our house, okay, synthetic fibers, the textile that we wear, plastics, paints. We cannot imagine our life without chemicals. How do chemical plants differ from the other process plants that are there? Chemical plants deal with physico-chemical transformation a substance into or a raw material into value-added product with input from various other resources such as manpower, energy, water, space and money. As we have seen in the module of flowsheet synthesis, the entire chemical manufacturing process is a combination of various unit processes and unit operations that are connected to each other. For instance, in case of a refinery, the crude oil is first distilled to separate various fractions such as the liquefied petroleum gas, that is hydrocarbons from C1 to C4, those carbons containing 1 to 4 carbon atoms, then the naphtha C5 to C10, then the gasoline which is C5 to C12, then kerosene which is in the same range, then high speed diesel, and then this operation is carried out by a series of distillation column. So, distillation is a major unit operation of the refinery industry. However, further in a petrochemical plant, the raw materials are different. For example, benzene is a major feedstock of petrochemicals. So, how a major route to benzene is the reforming of naphtha, steam reforming of naphtha. Now, in that process, naphtha is converted into aromatics, benzene, toluene and xylene, with aromatization as a unit process, and then there is separation of these aromatics, like benzene, toluene are easily separated, but separation of the xylene isomers is difficult. So, the orthoxylene comes out first, and then there is the isomerization of meta to para, and then para-xylene becomes a feedstock for terephthalic acid. Now, chemical projects differ from other projects such as automobile manufacturing project, hydropower generation project, highway construction, dam, so on and so forth, because these projects transform one substance into totally different substance. For example, the natural gas methane is converted into methanol in case of a methanol plant. Of course, there is an intermediate step of steam reforming of methane to generate the synthesis gas, hydrogen plus carbon monoxide, and that is contacted over a suitable catalyst to give methanol. Okay. So, this kind of thing is very unique to chemical industry. If you draw a simple flow sheet of chemical project, as we have seen in the flow sheet synthesis module, a chemical project has several inputs. First, the raw material, then utilities, then the technical know-how, and then the capital, money, and then there are several outputs, the main product, the byproducts which could be desired or undesired, and then we also get several waste streams which are known as effluent, which are in all three forms: solid, liquid and gas. The products and co-products are useful for the growth. However, effluents have negative impact on a society. Okay. Therefore, the chemical project involves the technical aspects of producing a product from the preferred raw material selectively and efficiently. So, we would essentially like to go for a zero discharge process in which there are no effluents. All of the raw material is converted into some product or byproduct. Toxic explosives, toxic and explosive nature of many chemicals can cause several harm, can cause several accidents and loss of life and wealth. Therefore, we would like to avoid the effluents as much as possible. So, that could be the major target or the major objective of design of a chemical project. It is not just about converting one material into another material, but as efficiently and as economically as possible. Okay. Chemical plants often require large quantities of water, so they cause burden on the society in which they are established. Chemical plants often require large quantities of water, and then they also require electricity. Water is required both in production process as well as utilities like steam and cooling water. The water that is rejected from the chemical plant becomes the aqueous effluent stream. It may contain biodegradable or non-biodegradable complex molecules. Therefore, we have to go for the waste treatment. If the waste streams are not treated properly to meet the stipulated local discharge standard, they can cause considerable damage to the environment and also to the social, and cause several social and economic problems downstream of the plant. So, we would like to avoid all these aspects while designing a chemical project. The gaseous emissions into atmosphere can cause devastating effect on human health, okay, as well as the plant and animal life. So, we have to see to it that the gaseous emissions are below the prescribed limits. Environmental related issues associated with chemical projects are assuming tremendous cost and credibility dimensions as time progresses due to stricter emission standards pertaining to gaseous, liquid and solid pollutants to have a quality of life. Chemical plants many times handle or generate flammable explosive materials, sometimes as fuel, sometimes as plant chemical. They are transported, they are received, uploaded, stored, handled at times under high pressure, temperature. So, in any of the processes, okay, leakage can occur which can cause tremendous damage, like the Bhopal gas tragedy is a very vivid example of such, or the scale of damage when proper handling and storage is not taken care of. The scope of a chemical project is extended from earlier like only chemical project to even power project based on liquefied natural gas. So, we have large reserves of this natural gas in the northeastern region. Okay, safety related issues arising out of huge shipment and storage of LNG might necessitate large allocation of areas for project and relocation of the villages. So, acquisition of land, rehabilitation of the people is another major issue associated with any project. So, chemical projects are no exception to these. So, these aspects give a total different dimension of safety, health and environment issues, what is known as SHE issues: safety, health and environment. Technical and commercial aspects along with social requirement need to be considered during the project evaluation, and then this SHE is a major aspect. Let us try to see what is engineering and what is economics. So far you have had courses in core chemical engineering such as mass transfer, heat transfer. In this course we are trying to couple a completely different subject to engineering, that is economics. Now let us see the difference between them. In a broader sense, engineering is applied science and effectiveness of engineering is measured in terms of profit or money that is generated by the activities that are ethically acceptable. Economics from engineering point of view is a perfect blend of art and science of production and distribution of wealth quantified in terms of money or profit. Therefore, if you see these arguments, then you can conclude that engineering and economics are two sides of the same coin, or in other words, it is very difficult to separate economics from engineering, or engineering is incomplete without having a proper economics background. Let us see what is chemical project engineering. Chemical project engineering could be termed as successful implementation of an idea into reality. When we say success, then obviously comes like what is defined as success. The success is measured in terms of three aspects. First, the profit or money that is generated. Then second, the non-monetary returns. And third are the social gains that are obtained before and after project implementation. The technical activities in the project engineering are system engineering, equipment design, material selection, procurement and coherent and comprehensive construction of all plant components into a production unit. So, that point we note. Success of project engineering is metered not only on the profit but also socio-economic gains. Engineering of a chemical project is a coordinated combination of technical and non-technical activities. Now, the technical activities we have already seen. Now, the non-technical issues include obtaining all the statutory clearances required for from various authorities such as the Pollution Control Board, the State Electricity Board, the procurement of land and plot, and finally, the timely arrangement of the required finance to implement the project. These are important because the timely construction of project is controlled by the availability of sufficient money as and when required. So, the capital you have to make sure, perfectly sure of your funds before you even start thinking of implementing a chemical project. Delays often cause project cost overrun, and then if your competitors enter the market before you, then you may lose the control over the market. Okay. The ability of a project to generate enough profit to return all borrowed capital for the project with interest to financial institution and dividend to equity holders has to be proven on paper a priori with detailed techno-economical feasibility report in addition to risk analysis to avail the finance from various sources. We are going to have a module on financial analysis of the chemical project. We shall see the capital cost, the operating cost, and then various measures of assessing the profitability of the process. But this is something which is very important, that first of all you have to prove the profitability on paper before you go actually into the project. Apart from financial aspects, there are legal and statutory matters that need to be addressed. For example, there may be legal matters pertaining to conversion of land into non-agricultural plot. There might be some public interest litigation against the project. So, you have to take care of all these things. Then the site specific clearances have to be obtained before you actually start the construction activity. And many times the market forces control the success of any business proposition. Market forces are very important. Very often market has to be developed, as in case of specialty products such as detergent and toiletries, cosmetics, etc. during project implementation. Hence, it is to be watched and the project is to be modified in capacity and contents accordingly. Whenever you are starting a project, you have to see the market that is in surroundings. For example, the project, suppose the project is started in southern India and the market for the product is in northern India, then you have to take into consideration the cost of transportation and the actual price of your commodity in the North Indian market. At that time, you have to also take into consideration what are your competitors from the local area, and then whether your product stands in terms of quality as well as price in comparison with the local competitors. The time factor is very important. The Time factor plays an important role in success of chemical project because of three reasons. First, long delay increases the interest on borrowing. If the all capital does not belong to you, if you have borrowed the capital either from the banks like IDBI, or if you have borrowed capital in the form of equities from people, you have to pay dividend and interest, and larger the delay, larger the interest on the borrowing. Second, project extension can change your market opportunities. As I just mentioned, if your project is not completed in time, your competitors may enter and they capture the market, and then the market hold goes down. And finally, the delay in the implementation can increase the project cost. We see several examples where the cost of the project has increased or even doubled in time because of the delay that has occurred. And obviously, all of these will affect your profitability adversely. So, it should be noted that interpreter is looking forward to generate profit through the project rather and at a rate higher than that obtained from banks. Like suppose some person is investing money, buying shares of your company, investing money in your company, then you have to make sure that to encourage him to invest to greater and greater extent, you have to pay dividend at a rate higher than those paid by bank. So, the banks are your competitor in the dividend. That point we have to note. Entrepreneur expects returns on investment at higher rate than given by banks. It is thus seen that for a chemical project, engineering and economics are not separable, and this is a topic that we address in this particular module of this course. So, this module is rather unique to all the courses that have been offered in the chemical engineering domain of NPTEL. Okay. Now, let us see what are the pre-project activities. Before you undertake any project, what are the activities that you have to do? First of all, defining a chemical project, or we can say, first of all, a project, whether it is chemical or otherwise, has to be defined before we take steps to implement it. Now, this basic requirement needs to be addressed mainly by the entrepreneur or managers that are engaged in corporate planning. Okay. Now, what are the questions that come up while defining a chemical project? The first question is what to produce. You have to first identify the product or a series of products. Now, this will require extensive foresight and knowledge of the current as well as projected demand supply of the market. Remember that it takes some time to build a particular plant, let us say 3 to 5 years. So, when you decide to produce a particular product, you do not have to consider the current demand and supply, but a projected demand and supply after 3 years or 5 years when your plant will be operational. Okay. And then how much of the market that you are able to access. Okay. That is important thing. If this step goes wrong, then a lot of valuable time in the project is lost. Okay. And there is a history of several project concepts failing at this particular first question, like what should be your main product. Okay. Then the next question that we face is the production capacity, size or capacity of the project. It is determined by two factors. First, the market share of the product, and second, the economic plant capacity below which the price is not competent in the consumer market. Now, remember, there is always an economy of scale. If you have put up a 10 tons per day plant and if you have put up a 100 tons per day plant, the per ton production cost goes down as the scale of production is increased. However, there is a limit as how much you can increase the scale. So, you have to do market analysis. You have to see how much share of the product market share you are going to achieve from your production, and then you have to decide the economic capacity of the plant, and you have to decide that particular capacity below which the price is. You have to identify the plant capacity below which the price is not competent, and then design a plant which is higher than that particular capacity. Now, there are examples where the markets were found to be far below than expectations after the plant was established, and also the capacity of the plant had to be doubled in few years to meet the overwhelming response from the market. So, you need to contact an expert which has several years of experience who can predict the market trend with sufficient accuracy. Okay. So, that is the second question in defining of a chemical project. The third question is how to produce. Okay. So, that questions we note before we go ahead, questions to be answered while defining project. The first two questions that we just discussed, what is the product or series of products, and second is the production capacity. The third question, the production technology, how to produce. Now, for any product, we are already in 21st century. For any product, there will be several processes available. So, before you decide to go for a chemical project, it is a good idea to look for the technologies that are available in the project. So, if you have done that homework, if one has the technology, then you save effort on technology search. But even then, you should always see whether any better technology is available, and secondly, is there any new technology that is under development. This is necessary because before investing into a project, it should be established that the project will not be technologically pushed into dustbin. Why? Because of the limitations or the constraint, government constraints. So, the safety, health and environmental issues, the energy conservation issues, okay, then the quality management issue, then the land that is required. Okay. So, you have to make sure that your technology is competent, not just because of the technology itself, but also the other related aspects as we just mentioned, safety, health issues, environmental issues, so on and so forth. So, when these basic questions are answered, the more important question about the project cost and financing will have to be addressed. So, before you go for detailed analysis, make sure that your technology is competent in every aspect. It is not only just low in the production cost, efficient in terms of the desired product, but it should also have least emissions, it should have least hazardous conditions, so on and so forth, to meet all the criteria or the constraints that are imposed by the government. The total project cost is typically the fixed capital investment plus working capital. So, the cost of production gives you an idea of the day-to-day expenses. Okay. Now, then after you decide technology, you face two more questions. First, what are the returns on the project? What is the raw material that you are going to use, and what is the cost of the product that you produce? So, that difference gives you the value addition, and is the value addition sufficient enough to make the investment attractive? That is the question. Okay. Investment should be attractive in comparison with alternate investments. As I just mentioned, that if you have to attract an investor for buying shares of your company, you have to promise him dividend at a significantly higher rate than those offered by the nationalized banks or even the cooperative banks. Then the second question that will come is that will project survive long enough and grow? Now, this question is very tricky. Very obviously, the returns on projects are possible only if there is sufficient market for your product. Okay? And then your product has to withstand the competition from other manufacturers. Okay? The market will allow growth in demand, which can be best met by expansion of the plant capacity. what is the optimum capacity? The optimum capacity as will be determined the market forces. However, you should be able to go for change in production. Your production capacity should be flexible to meet the project demands. So that is thing. Project will grow obviously if the demand is increasing, or you are able to capture more and more share of the market by expanding in different parts of the country or having collaboration with other companies, local dealers, so on and so forth. So these are the questions that we have to answer while defining a project. Having answered these questions, the next thing is the type of the project or classification of the project. The chemical projects are broadly classified as either the grassroots project or add-on project. What is a grassroots project? Grassroots project is a plant designed from scratch, a plant constructed from zero level and almost on a barren land, starting from land procurement and site development, is referred to as the greenfield or grassroots plant. So there are several examples of it. Gas cracker complex at IPCL in Nagothane. Okay, it was built on the land that was partly agricultural and partly hilly and barren, and then you have to see to it that it gets a proper feedstock from various sources. Then you have to go for infrastructure development, water, you have to make sure of water, power availability, housing and educational facilities for your personnel. However, every greenfield project may not necessarily include the development of the entire infrastructure. Therefore, you can at the start of the plant, you can postpone some of these activities in the later period of the project. Okay. So that is the grassroots project. The second type of project is what is known as the add-on project. Now these projects are built within existing complex. Okay. An example of it is a small plant for recovery of a valuable product from waste stream of an existing plant. Okay. Now whether to go for such add-on plant depends on the financial condition of the company. Okay. If company has sufficient financial reserve to go into new venture, then all of these projects fall into the category of add-on projects. Okay. So that is it. These projects, add-on project, could be of several subtype. Okay. What are these? One is what is known as a battery limit project. Battery limit project by definition is a new plant using most of the available infrastructure of an existing plant, such as the utilities, administration building, security, tanks or the storage area, storage facilities, the effluent treatment plant, so on and so forth. The example of this is a plant to manufacture technical grade fumaric acid by scrubbing of gases of phthalic anhydride plant using orthoxylene as feedstock. Okay. So this could be deemed as a battery limit plant. Then the next category is that of forward integration. Forward integration is essentially a project based on the products of existing plant as raw materials. Suppose you have several byproducts of your company which are not so harmful, which can be further upgraded to different value added products. In that case, you would like to go for forward integration of the company by installing new plant. Now example of this is if a phenol manufacturer decides to set up a bisphenol A project based on phenol and the co-product acetone, then this particular activity could be deemed as a forward integration, okay, of the existing plant. Then second, the third subcategory of add-on project is that of backward integration. Okay. If the project owner decides to manufacture the raw material for the existing project, then it can be deemed as the backward integration of the plant. An example in this category is that of diphenyl carbonate. Okay, when diphenyl carbonate is being manufactured using phenol and diethyl carbonate by an eco-friendly and safe technology, and the owner decides to set up a plant to manufacture diethyl carbonate, then that activity could be deemed as the backward integration. Then the fourth subcategory of add-on project is expansion of the project. Here it is simple addition of more capacity to existing facility, keeping the product and raw material same. That example could be adding naphtha cracker to the cracker complex to enhance the ethylene capacity. Okay, it could be called as expansion project or also known as horizontal integration. The fifth type of add-on project is that of diversification. the project owner may totally diversify into different product range. Like for example, a petrochemical producer, like the one who does steam reforming of naphtha to produce aromatics, could go for diversification in power generation. Power generation, we in India are tremendously short of power. So anyone who is generating power is going to make a lot of profit. That is why we see several private companies setting up power plants besides their refinery. So that could be a sort of a diversification. And then this electricity they can use not only for captive consumption, that is to meet the internal energy demands, electricity demands of the process, but they can also sell it to the government and the people. And the sixth type of add-on plant is what is known as a debottlenecking project. Debottlenecking project can be defined as replacement of the equipment and system in an existing plant to increase the production capacity, but using the same raw material and the products. An example of this category is the existing distillation tower with Paul rings as packing material could be replaced with multi-filament wire gauze packing, or what is known as IM tip, interlocks metal tower packing, which have a low pressure drop as well as lower HTP, height equivalent to theoretical plate, so that you get products of better quality. So these are some of the examples of add-on projects. Let us see what are the other factors that are involved in classification of a chemical project. If we see a broad classification, then we can classify into three categories, okay, based on three different criteria. Further classification of chemical. First, classification, or let us say we write here criteria first. Further classification of chemical projects. Criteria, first is the price and size of a product. Now here products are classified as either basic chemical, like basic chemical could be methanol, ethanol, methane, ethane, ethylene, these are the basic chemicals. Then the commodity chemical, commodity chemicals could be fertilizers, could be soaps, detergents, or specialty chemicals. Specialty chemicals could be the pharmaceuticals. The second criteria is that of the capital outlay or investment of the project. Here there are three categories. First is a mega project involving thousands of crores, then medium size, maybe few hundred crore, and a small scale project which could be up to 100 crore. Okay. Well, of course, these are very broad classifications. Then the nature of the product based on the industrial sector. As fertilizer or pharmaceutical. Now let us discuss each of these criteria in greater detail. Okay. Now first, the price and size of product. As I just mentioned, the basic chemicals are the building blocks of chemical industry, and these are consumed in large quantities and by themselves, and they do not have any direct consumer application. Okay. However, they still control the end market. Therefore, they are produced in bulk to meet the market requirement and to derive economic benefits of size. Okay. So, the basic chemicals are low priced chemicals, high volume chemicals. So, examples I have already given, like methanol, ethanol, ethylene, propylene, benzene, sulfuric acid. Okay. These projects need large investment and the capacities are also quite high. For example, the capacities could be 300,000 tons per annum of ethylene. Commodity chemicals are produced in quantities in similar range, but the production rate is typically less than 100,000 tons per annum. Okay. Now, as I said, these are commodity chemicals are basically fertilizers like urea or phenol or polyvinyl chloride, polymer or something like acetic acid. Okay. Now, these also have a direct or indirect impact on the market. Okay. Market forces govern their prices and therefore, they have to have certain price range rather than a unique price. Specialty chemicals are high value chemicals and low volume. So, that point we note. And many times the technical know-how of the specialty chemicals is quite guarded. Okay, so most of the things are patented and not available as regular technology. Then the project capital outlay, I already said, mega project is typically in the range of 10,000 crores, thousands of crores. Large project could be between 1,000 to 10,000 crore. Normal project could be between 100 to 1,000 crore. Small project could be in the range 25, 50 or at the most 100 crores, okay, so on and so forth. So that is a criteria of project capital outlay. Then the criteria of industrial sector. Now, industrial sector could be grouped in several broad industrial industries. So, you can group industry into several sectors, okay, like for example, petroleum refining is one sector. Then petrochemicals is another sector. Then agrochemicals. Then dyes and paints, so on and so forth. One more category could be listed as insecticides and pesticides. Then next is the price of a particular product. We know two words in common man's language, price and cost. Now, literally these could be synonyms, but when we talk from economic point of view, they are different. So, how these are related? Price is essentially cost plus profit. Okay. Now, how do you decide the price of a product? Okay, purely on economic consideration. That can be done as price, which is the transfer price, is equal to beta, a constant, into the project cost plus the gross cost of production. Now, this factor beta essentially implies the return on investment, and beta has to be at least 1 minimum value. Let us see briefly the activities that are from project conception to project commissioning. The project goes through various steps and sequences before it is fully implemented. Okay. Some of these take long time and almost go to and fro before it is confirmed, and the action mainly in terms of major commitment or expenditure is taken. So, we shall try to see the different activities that are there. Okay. We only summarize, for greater discussion we will see in the next lectures, the milestone of project implementation. Some of the steps, as I said, in the project development will be taken by the owner of the project, while some may be outsourced to consultancy agencies and the project engineering companies. Okay. Now, all the know-how may not be available with the project owner. So, things like site survey, site assessment, this could be lent to this kind of jobs could be given to project engineering companies. Okay. Now, the first is project conception. Okay. Project can be conceived from business and market opportunities, new materials and technologies that are available, then consumer feedback, opportunities made available by global politics or simply out of the statutory compulsions such as to treat the waste of an existing unit. Like an example of this category is the government policy of making petrol lead free. So, instead of tetraethyl lead, the manufacture of ethyl tertiary butyl ether ETB started as the octane booster in the petrol. So, that could be the seed for the project conception, okay, such kind of policies. Then the second is the market potential. Okay. We have to consistently look for market potential, okay, and it has to be established for the proposed product by way of quick desk study. This has to be supplemented later with more reliable field study when large expenses are to be incurred on the project. Then the technology search, this I have already mentioned that it is a good idea to do the homework of technology search before you decide to take up a project. But although you have an information available on the available technologies, you have to look for developing technologies or technologies that are recently or very newly implemented. Then the preliminary feasibility report. This report has to be prepared to aid the investment decision. It is found worth going ahead, then a detailed market potential based on the desk study as well as field study may be commissioned. Remember, doing market survey is no simple job. You have to contact experts, you have to pay them lot of fees. Therefore, before you go into that, you have to make sure, very sure that your project is profitable and it is worth going for. So, that will be done by the preliminary feasibility report. Then the detailed technology search and evaluation. Now, with help of competent project engineering companies, okay, you have to go for a detailed process or technology selection. Then you may have to sign MOU, memorandum of understanding, to be executed at this stage with the process know-how licensor, and you have to find a detailed engineering contractor. Then comes the task of site selection. The site of the proposed project need to be selected. Site selection is a different topic in this particular module. I defer greater discussion later in this module. Then preparation of the detailed techno-economic feasibility report. This results in what is known as the bankable document to obtain loan from financial institution. And then the statutory clearances. We have to obtain several clearances and approval from the central government as well as state government agencies, local statutory bodies such as Ministry of Environment, Ministry of Finance, Ministry of Forests, okay, and so on and so forth, with help of HAZAN, the hazard analysis, and HAZOP, the hazard operability studies. Okay. Environmental impact assessment study may also have to be taken into consideration. Then you have to look for a contractor, contractor for know-how and detailed engineering. Contract should be signed with a process licensor to supply of know-how. Contract should be signed with a detailed engineering contractor. Many times the contractor is recommended by the process licensor, so that saves you some job. Then comes the very important factor of project financing. By and large, the project is not totally financed by the promoter or investing the entire capital. Project owner may not invest entire capital. Some capital may be his own, some may be borrowed through bank, and some may be borrowed in the form of equities. So, that financing you have to make sure before you go ahead. Okay. Then the project engineering. Now, this project engineering involves detailed engineering, then procurement and procurement of all equipment, then expediting inspection services, followed by construction of the plant, and finally comes the project commissioning. That is, after construction is completed, the mechanical commissioning of the plant is carried out. Okay. This is followed by process commissioning, during which the guarantee runs are performed by the process licensor, and then the project is handed over to the production personnel. Remember that if the plant is designed for capacity, let us say 1000 tons per day, it may not achieve that particular capacity right in the first year. So, the capacity increases over years. So, maybe in the first year the plant operates only to 60% of the capacity if the other factors are not, like for example the utilities like cooling towers or steam generating plants. If those do not go hand in hand, then it need not be that all construction may be complete and then you start. You can start production before the entire construction is taken over, but to a lower capacity. That is always feasible. So, that is what is known as project commissioning. In the subsequent lectures, we shall take up issues pertaining to the subject of chemical project economics, such as the first of all estimation of the cost, then second the profitability analysis, then the depreciation, and then other factors.